This is the notes for 6F, Solving Absolute Value Inequalities. This is part of your Unit 3 packet for absolute value. So in the video, we'll go over the notes and then select problems from the practice worksheets. I expect you to try all the practice problems that we do together, and then you'll complete the worksheet for the level that you're on, 1, 2, 3, or 4, based on the pre-assessment on Canvas you took earlier. If you're not sure what your level is, refer back to your score from the 6F pre-assessment. Okay, let's recall each of the different inequality symbols. This first symbol is the greater than symbol. This is the less than symbol, greater than or equal to, less than or equal to. For the graph, we'll have open holes for greater than, less than, and parentheses. For greater than or less than or equal to, we'll have points and brackets. Let's try these examples right here for solving linear inequalities. So the first one says 5x minus 2 is less than 3. To solve this one, we're going to add 2 to each side, so that we have 5x is less than 5. Divide each side by 5. So that's 1x is less than 1. So we'll plot 1 on the number line with a hole because there's no line. X is less than, so we're going to shade in the left side. As long as we have the variable on the left side and our constant on the right side, this inequality sign should be pointing to the way that we're supposed to be shading. Notice we have an arrow pointing to the left, and then this is pointing to the left. They're both shaded in. Remember, that only works if the variable is on the left side. If you were to write this in interval notation, it would be parentheses negative infinity to 1 parenthesis. Let's do the second one. Negative 3x is less than 6. Divide each side by negative 3. So if x is greater than negative 2, we'll flip the inequality sign whenever we multiply or divide by a negative number. So then we have x is greater than negative 2. So we'll plot negative 2 on the number line, and then we're going to shade the right side. Our interval notation would be negative 2 to infinity. Let's look at the first example in our table. We have the type of function, type of equation here, absolute value of A equals B. So you're going to have your negative piece and your positive piece. This should be a review from the last set of notes for 6E. So we have negative 2 times the absolute value of x minus 1 plus 4 equals negative 6. The first thing you want to do is isolate the absolute value. To do that, we'll subtract 4 from each side. And then divide by negative 2. So we have the absolute value of x minus 1 equals 5. And then you will set up your two pieces and solve them. So if x minus 1 equals negative 5 for your negative piece, and then for your positive piece we have x minus 1 equals positive 5. Solve for each piece. Add 1. So if x equals negative 4, or add 1, x equals 6. There's no extraneous solutions to check for, so those are both real solutions. On the number line, we'll plot those 2 points. negative 4 and 6. And then there's nothing to shade in besides the 2 points because this is an equation, so only finding those 2 critical numbers, those 2 solutions. Let's look at the second one. This type is the absolute value is less than or equal to b. When you have that, it's an and compounded equality. With a is greater than or equal to negative b, and a is less than or equal to b. You could also write that as negative b is less than or equal to a is less than or equal to b. We have absolute value of x divided by 9 is less than or equal to 4. So that's your given inequality. Now you want to isolate the absolute value part. To do that, we're going to multiply each side by 9. So we have the absolute value of x is less than or equal to 36. Now you want to set up your 2 pieces, your negative piece and your positive piece. When we set up our negative piece with inequalities, we also flip the inequality symbol because you're really dividing by -1 here. And then for the positive piece, it's still just x is less than or equal to 36. Basically, you just take away the absolute value sides, and that would be it. This would be an and, because our isolated absolute value has a less than sign. So then you can rewrite this as negative 36 is less than or equal to x is less than or equal to 36. This would be your solution. So we'll plot those 2 points on the number line with filled in points. Since x is in the middle, we're going to shade the middle part of the number line. Let's look at the next type. We have the absolute value of a is less than b. This one still has a less than type, so we'll have an and compounded equality. A is greater than negative b, and a is less than b, which could be rewritten as negative b is less than a is less than b. We have the given inequality. -2 times the absolute value of x minus 1 plus 4 is greater than -6. The first thing you want to do is isolate the absolute value. Subtract 4 from each side. And then divide by -2 each side. We divided by a negative number, so that means we're going to flip that inequality sign. Set up your 2 pieces. So for a negative piece, we have x minus 1 is greater than -5. And then for a positive piece, we have x minus 1 is less than 5. The word we'll put in the middle is and, because of the form. We have a less than sign with our isolated absolute value. We'll solve for each piece, add 1. X is greater than -4, and add 1. X is less than 6. So we have x is greater than -4 and x is less than 6. We can rewrite it like this. And then we'll go ahead and graph it on the number line. Open holes. And x is in the middle, so we're going to shade in between. Let's look at the next type. We have the absolute value of a is greater than or equal to b. We have an absolute value that's greater than. It's going to have an or compounded equality. A is less than or equal to -b, or a is greater than or equal to b. So we have our given inequality, -8 times the absolute value of -3a minus 3 minus 2 is less than or equal to -98. we want to isolate the absolute value first. So we'll add 2 to each side. And then divide by -8 for each side. We divide by negative, so we're going to flip the relation sign. From there, you're going to set up your 2 pieces, your negative piece and your positive piece. Solve for each. Remember, when you do your negative piece, you also flip the inequality sign. The word we'll put in between is or. Okay, we'll solve for A, add 3. Divide by -3. So we have A is greater than or equal to 3. Or, let's solve for the positive piece, add 3. Divide by -3 each side. A is less than or equal to -5. And we're going to have an or in between. And here's what your solutions would look like. Inequality and interval. On the number lines, we'll plot our 2 points. -5 and 3. Since it's or, we're going to shade the outside. Now let's look at the next page. We have the type absolute value of A is greater than B. This is an or compound inequality. A is less than -B, or A is greater than B. We're given the inequality -2 times absolute value of x minus 1 plus 4 is less than -6. We will isolate the absolute value. To do that, subtract 4 from each side. And then divide by -2 each side. So then we have absolute value of x minus 1 is greater than 5. So then we have our negative piece, x minus 1 is less than -5, or our positive piece, x minus 1 is greater than 5. Solve for each piece. Add 1. So x is less than -4, or for the positive piece, add 1. X is greater than 6. So then on the number line, we'll draw our 2 holes, put -4 or 6, and then shade the outside. Here's what our solutions should look like. An inequality notation and interval notation. Let's look at the next type. We have absolute value of A is less than or equal to -B, where -B doesn't equal 0. You would have no solution, because absolute value can never be less than or equal to a negative number. So the first thing we want to do with this given equation, -2 times the absolute value of x minus 1 plus 4 equals 6, is to isolate the absolute value. Subtract 4. We have -2 times the absolute value of x minus 1 equals 2. Divide each side by -2. So the absolute value of x minus 1 equals -1. From there we can stop, because the absolute value of something can never equal a negative number. That would be no solution, the empty set. And for the number line, you would just leave it blank, because nothing's shaded in, because there's no real solution. For this next type, we have the absolute value of A is greater than -B, where B is not equal to 0. You would have infinite solutions. because an absolute value will always be bigger than a negative number. So the first thing you want to do for negative absolute value of x is less than 7 is to isolate the absolute value. Divide each side by -1. So if you have the absolute value of x is greater than -7. That'll always be true, so that's all real numbers, infinite solutions. And on the number line, you'll just shade in the whole thing. Alright, let's look at the last example from this table. This one we're going to check for extraneous solutions at the end. So we're given the absolute value equation, -2 times the absolute value of x minus 1 plus 4x equals -6x. We want to isolate the absolute value, subtract 4x from each side. Divide each side by -2. So we have the absolute value of x minus 1 equals 5x. So we'll just put that off to the side right there. That's our isolated absolute value equation. So we're going to set up our positive part, our negative part, and solve for each. So our negative piece would be x minus 1 equals -5x. And our positive piece would be x minus 1 equals +5x. So subtract x, divide by -6 each side. 1/6 equals x, or subtract x from each side. Divide by 4 each side. So x equals -1/4. So we want to check both of these to see which one is real, which one's extraneous, or if they're both real or both extraneous. So let's try the 1/6 first. A 1/6 minus 1, is that equal to 5 times 1/6? 1 is the same thing as 6/6. So we have the absolute value of -5/6. Is that equal to 5 times 1 is 5, so we just have 5/6 here. This is true, so that would be a real solution. Now let's look at -1/4. Absolute value of -1/4 minus 1, is that equal to 5 times -1/4? Okay, so we know that the right side of the equation is going to be -5/4. We know that absolute value can never equal a negative number, so we can stop there. We don't even have to add or subtract these fractions. So that's false. So this is extraneous. So on the number line, we would just graph the real solution, 1/6. So your solution is just 1/6. Okay, now we'll go ahead and go through some of the select practice problems from the worksheets. I want you to try each of the ones that we do, and then you'll complete the worksheet for the level that you're on. Again, refer to the pre-assessment for 6F to see which level you are. Okay, for this 6F level 1 worksheet, let's go ahead and do number 6 and 8. For number 6, we have the absolute value of r plus 9 is greater than or equal to 17. Well, it's already isolated, so we're just going to do our positive piece and our negative piece separately. Solve for r on both. If you refer to the notes for the previous page, we have a greater than or equal to. so we're going to put or in between. Okay, we'll solve for r, subtract 9. So r is less than or equal to negative 26, or subtract 9 from each side. R is greater than or equal to 8. So on the number line, we'll go ahead and draw those two numbers with points. And then we'll shade the outside because it's or. Let's look at number 8. The absolute value of a divided by 9 is greater than 1. We will isolate the absolute value first. To do that, we'll multiply each side by 9. That's 1. So we have the absolute value of a is greater than 9. Greater than means that we're going to put or in between our positive and negative pieces. So our negative piece is a is less than negative 9. And then we'll put or, the positive piece. A is greater than 9. There's no solving left here, so those are your solutions. We have negative 9 with a whole, and we have 9 with the whole. And we'll shade the outside because it's or. Alright, let's look at the 6F Level 2 worksheet. Number 4 and 5. So for number 4, we have the absolute value of x divided by 9 plus 2 is greater than or equal to 3. First, we will isolate the absolute value. To do that, we can subtract 2 from each side. So we have the absolute value of x divided by 9 is greater than or equal to 1. It's greater than or equal to, so we're going to put or in between the two pieces. Negative piece, we're going to have x divided by 9 is less than or equal to negative 1. And then for our positive piece, we'll have x divided by 9 is greater than or equal to 1. To solve, we'll multiply by 9 for each thing. So then we have x is less than or equal to negative 9, or x is greater than or equal to positive 9. So we'll draw those on the number line. And then we're going to shade the outside because it's or. Okay, let's look at number 5. 3 times the absolute value of n plus 6 is less than 21. The first thing we do is isolate the absolute value. We can subtract 6 from each side. And then we have 3 times the absolute value of n is less than 15. Divide each side by 3. We have n. The absolute value of n is less than 5. It has less than, so we're going to put an and in between them. Our negative piece and our positive piece. So our negative piece would be n is greater than negative 5. And then our positive piece would be n is less than 5. So we'll go ahead and plot those 2 points with holes. And then it's an and, so we're going to shade in between. Now let's look at the 6F Level 3 worksheet. We'll look at numbers 7 and 10. Number 7 has the absolute value of k plus 2 plus 8 is less than 17. The first thing you want to do is isolate the absolute value by subtracting 8 on each side. So we have the absolute value of k plus 2 is less than 9. It's less than, so in between the two pieces we're going to put and. So for a negative piece we have k plus 2 is greater than negative 9. And then for a positive piece we have k plus 2 is less than 9. Solve for k on each. Subtract 2. We have k is greater than negative 11. And subtract 2. K is less than 7. So we're going to go ahead and graph these two with wholes. So I have negative 11 and we have positive 7. It has and, so we're going to shade in between. And let's look at number 10. The absolute value of 2 minus 8n divided by 7 is greater than 4. We will isolate the absolute value first by multiplying each side by 7. So we have the absolute value of 2 minus 8n is greater than 28. It has a greater than sign, so we're going to put or in between our negative piece and our positive piece. So for our negative piece, we have 2 minus 8n is less than negative 28. Or for a positive piece, we have 2 minus 8n is greater than 28. Solve for n for each piece. So subtract 2. We have negative 8n is less than negative 30. Divide by negative 8 each side. So then we have n is greater than 30 over 8. We could just leave it as a fraction. It doesn't simplify any more than that. And then or the positive piece. Subtract 2. Divide by negative 8. And then we have n is less than. We could simplify this by dividing each by 2. Negative 13 over 4. So we'll go ahead and plot each of those on the number line with wholes. So we have negative 13 over 4, and then we have 30 over 8. It has or, so we're going to shade the outside. Let's look at the 6F Level 4 worksheet now. We'll look at numbers 8 and 10. So let's look at number 8. We have negative 2 times the absolute value of negative 2 plus 2/3 m minus 5/9 is greater than or equal to 43 over 9. First thing we want to do is isolate the absolute value. We could do that by adding 5/9 to each side. They both have a common denominator, so we could just add those straight across. So I have 48 over 9. Divide each side by negative 2, which is the same thing as multiplied by negative 1/2. Half of 48 is 24, so we have negative 24 over 9 right here. We divide by negative numbers, so we're going to flip that inequality sign. There's a less than or equal to sign right here, so in the middle of the two pieces we're going to put and. For our negative piece we have negative 2 plus 2/3 m is greater than or equal to, or Actually, we could just write down what we already had, negative 24 over 9. And then the positive piece would be negative 2 plus 2 over 3m is greater than or equal to 24 ninths. Now, if we were to solve for each of these, they would both be extraneous solutions, because if you look at the isolated absolute value inequality, we have that the absolute value is less than a negative number. So that's no solution there. So you would leave the number line blank, and then you'd put the empty set. Now let's look at number 10. We have 4.2 times the absolute value of 5b minus 5.5 plus 0.9 is less than 76.5. The first thing we'll do is isolate the absolute value. We could do that by subtracting 0.9 from each side. And then we would divide each side by 4.2. So this is 1. So we have the absolute value of 5b minus 5.5 is less than 18. Since there's a less than symbol, there will be an and in between the two pieces. So for our negative piece, we have 5b minus 5.5 is greater than negative 18. And then for our positive piece, we have 5b minus 5.5 is less than 18. Okay, we'll solve for b on both. So add 5.5. Divide by 5. You get b is greater than negative 2.5 and add 5.5. The 5b is less than 23.5. Divide by 5. And then you have b is less than 4.7. So your solution would be negative 2.5 is less than b is less than 4.7. And then you would plot these with holes on the number line. So we have negative 2.5 right here, and then we have 4.7. B's in between, so we're going to shade in the middle. So remember, you need to complete the practice worksheet for the level that you're on. Refer back to your 6F pre-assessment score for that. There is a key in the back of this packet for you to check your work. Again, to get credit, you do need to show your algebraic steps. Don't just copy down the answers. When you're finished with your practice worksheet, do your cherry quiz for 6F on Canvas. And then we'll do the checkup quiz for 6F next time. If you ever have any questions over this stuff, be sure to let me know. Send me questions on Remind, or if you're watching this during class, you could ask me there too.